Alright, we're going to start with section 7.1, Angles of Polygons, and we need to recall how to classify them from section 1.4. Our objectives are to use interior and exterior angles, measures of polygons, and our essential question is what's the sum of the interior angles of a polygon and the exterior angles of a polygon. So recall from 1.4 when we talked about the different number of sides and shapes, so fill in your chart. Let's take a quick couple seconds here to refresh our memory on polygons. We know they're plane figures, they're closed, they only have two lines that can meet at a single vertex, so no two polygons pushed together, and there are no curves, so it's just line segments. So circles are out, they're not polygons. And then here are some additional examples of other figures that are not polygons. Alright, so recall we have two types of polygons. We've got our convex, which are no lines on the interior of the polygon when we extend them all. So we can see that no sides are on the interior of the polygon. This would be a convex. Concave is not convex, so when I extend all the sides, they will intersect on the inside, as you can see in these two examples. Alright, so is this a polygon, and what are its attributes? So we know that it has 1, 2, 3, 4, 5, 6 sides, so that's a hexagon. And then when I extend all the sides, no sides are the interior, so it's a convex. So it's a convex hexagon. Alright, so next we have a table that we're going to fill in with some information about the number of sides of a shape and the sum of the interior angles. So we'll start with the triangle, because that's what we're most familiar with. Triangles have three sides. And we also know that the interior angles all add up to 180 degrees. So 1 times 180 is 180 degrees. It may be a little strange that we put 1 times 180, but as we move through the table, it'll make more sense. Alright, next sided figure, we have a quadrilateral, which has 4 sides. And here we're going to divide the triangle with a diagonal. So just to be clear, a diagonal is a segment that joins two non-consecutive vertices. And we can see that when I connect two non-consecutive vertices, the diagonals divide the polygon into triangles. How many triangles do we have? We have 1, 2. So the sum of the interior angles would be 2 times 180, because there's two triangles that are each 180 degrees, for a total of 360 degrees on the interior of a quadrilateral. Next, we have the pentagon, which has 5 sides. So how many diagonals would this one have? At most, we could sketch in 2 diagonals in a pentagon, which gets us 3 triangles. 1, 2, 3. So because we have 3 triangles, and each triangle is 180 degrees, we can multiply to get the interior sum of the interior angles. So all 5 angles would add up to 540 degrees. Let's take a look at the hexagon. Hexagon has 6 sides, and it can be divided up into 4 triangles. So I can get 3 diagonals. So if there's 4 triangles, the sum would be 4 times 180, which gets us a total of the interior angles of a hexagon to be 720. So as the polygons increase in sides, the sum of the interior angles also increases. Alright, let's check out a pattern here. For the first triangle, first polygon, we had 1 triangle with 3 sides. For the second polygon, we had a quadrilateral which had 2 triangles, 4 sides. And for a pentagon, we got 3 triangles and it had 5 sides. And for the hexagon, we got 4 triangles and it had 6 sides. Do we see a pattern here? Hopefully you see that they all have a common difference. In other words, 3 minus 1 is 2. 4 minus 2 is 2. 5 minus 3 is 2. And 6 minus 4 is 2. This leads us to the polygon interior angles theorem. The sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180, n being the number of sides. So no matter what number of sides we have, we can always use this formula to find the sum of the measures of the interior angles of any polygon. So if it's a 20-sided polygon, we'd plug in 20 for n, subtract 2 from it, and then multiply by 180, and that will get us the sum of all the angles. So let's look at an example together. All right, so let's take a look at this example. Find the sum of the interior angles of the figure. So count the number of sides. You got 1, 2, 3, 4, 5, 6, 7, 8 sides. So when we plug it into the polygon interior angles theorem formula, we get 1,080 degrees for all the interior angles of this 8-sided figure. All right, pause the video and you find out the sum of the interior angles of a dodecagon. All right, once you plugged in 12, which is dodecagon, into the formula where n is located, then you work it out and you get 1,800 degrees. Next, let's look at going backwards. So let's say we know the sum of the interior angles and we want to know how many sides there are. Still use the same formula, but you'll plug in 900 after the equal sign because we're trying to solve for n. So you would divide both sides by 180, then add 2, and you get 7 for this particular example. So the polygon has 7 sides. In other words, it's a heptagon. Then we have the corollary to the polygon interior angles theorem, which states that the sum of the measures of the interior angles of a quadrilateral is 360 degrees. So let's use this example 3 to find value of x in the diagram. All right, using this corollary, we can write an equation. So we have x plus 108 plus 121 plus 59 equals 360. So we solve for x, and we get x equals 72. So the value of x is 72. And let's just talk real quick about regular polygons. A regular polygon is a polygon with all sides and angles congruent. So if we look at the progression here, an equilateral that has all sides congruent, and then an equal angular is a polygon where all the angles are congruent. So we put those two together, those two ideas, and we've got a regular polygon. A regular polygon is both equilateral and equal angular. So, since a regular polygon has all sides and angles congruent, what if we wanted to find one interior angle of a regular polygon? So we would take our sum of interior angles formula and just divide by the number of sides. And if we do that, then we get each interior angle. So let's look at this example where we're going to find the interior angle, each interior angle of a regular dodecagon. So start by writing the formula to find each. So n minus 2 times 180. So this is the sum of all interior angles. And then you're going to divide by the number of sides. So we substitute 12 because dodecagon is 12 sides. And we substitute 12 into both places where we see n. So each interior angle of a dodecagon, regular dodecagon, would be 150 degrees. Well, what about our exterior angles of a polygon? Extend the sides of all of my sides. Each side extended creates an exterior angle. So we know that the interior angle plus the exterior angle is going to be 180 degrees because it's a linear pair. So each linear pair is 180 degrees. 180 degrees, 180 degrees, 180 degrees, 180 degrees. So if I've got 5 of these 180-degree linear pairs, 5 times 180 is 900 degrees. So let's simplify this. We've got 5 times I plus 5 times E equaling 900 degrees. Combine like terms. Substitute in 540 for the 5i. We know that the sum of the interior angles of a pentagon is 540. So that's where the 540 came from. Subtract 540, we get 5e equals 360. That means the sum of all exterior angles on a pentagon is 360 degrees. And if we divide that on both sides, we get 180. Divide 5 on both sides and get 180 degrees. So, Polygon exterior angles theorem states that the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. Let's look at this in a different way. If at each step 1, shade one exterior angle at each vertex, and then step 2, if we were to cut out all those exterior angles and put them together, it would definitely arrange a complete circle. So you can think of it that way. All the exterior angles of a polygon is 360 degrees, and it doesn't matter what size polygon you have. This is true for all polygons. So if I wanted to find out the exterior angle of each side of a regular polygon, I would just take that 360 total and divide by the number of sides. So let's take a look at this example. Find the value of x in the diagram. So we can see that in this picture, all the sides of the polygon are extended, therefore creating exterior angles. So these are all exterior angles. So start by using the polygon exterior angles theorem to write an equation, and then once you write your equation, you solve for x. So in this case, we would say that all these exterior angles added together, so create that part of the equation, and we know that it's going to add up to be 360. So we say equals 360, solve for x is 68, so the value of x is 68. And then you can plug in to figure out your exterior angle measures. All right, let's take a look at some examples. So find the number of sides of a regular polygon with each interior angle equaling 160. So we first have to note that it's a regular polygon, so that means all the sides are the same length, all the angles are the same measure. And we want each interior angle, which is 160 degrees. So we know the interior angles. So we consider the two formulas where we were dealing with each. We've got each interior, which is this formula here on the left, and then we've got each exterior, which is this formula on the right. So just based on the fact that we're dealing with interior and each interior, we're definitely dealing with this formula, you would think. But based on the information we just learned, it would be easier to use this formula, because we know that since each exterior plus interior is 180 degrees, in other words, a linear pair, and we know that each interior angle is 160, we can subtract 160 from 180 to get the exterior angle, which is 20. Once you know the exterior angle, you can set up a proportion. So we have 360 divided by n, that equals each exterior angle, so then put that over 1. Then you cross multiply, getting you 20n equals 360. Divide both sides by 20, so we have an 18-gon sided figure. All right, so take a minute to try these two on your own, putting it all together. This is our final example. All right, did you get 150 degrees for each interior and 30 for each exterior? If not, pause the video to look at all the explanation and see where you might have made a mistake. And that is all for this year. See you next year. Happy New Year.